Thank you for watching this video from Hexagon Geospatial on data preparation and basic exploitation workflow using ERDAS IMAGINE 2016 tools. Let's have a brief introduction on the tools used in the workflow. Shoebox tool for the organization of project data, compute pyramids and statistics, to view and edit the image elements. Preference editor for customization of ERDAS IMAGINE. Elevation Library Manager, a single centralized catalog of elevation data sources. Ortho Rectify without GCP tool to create ortho image with imagery and model selection and no GCPs. Pan sharpening tools to integrate imagery of different spatial resolution. Let's start with the shoebox. Let's add a shoebox. Shoebox facilitate in the structure and organization of all working data associated with the open project or projects to accomplish a task. Add a group. Rename the group. Add a set of files to the group. Select the files to open as virtual mosaic. Fit to frame. Right-click on Project Data 1 group and select Add New Outputs. Collecting Output Files layer is added. This ensures Project Data 1 group is ready to receive any new output files. Save the virtual mosaic. Remove the virtual mosaic from the viewer. Observe that the saved mosaic file is added to Project Data 1 group. Select the files to open as virtual stack. Fit to frame. Vary the band combination. Remove the virtual stack from the viewer. Add a new group. And load a raster vector and an AOI. Remove the collecting output files layer from first group and add it to the second group. Drag and drop the raster, AOI and the vector files into the viewer. Modify the area fill of the vector file. Save and remove the vector file. Save the symbology file and observe that the EVS file is added to Project Data 2 group. Clear the viewer. Save the shoebox. Remove the shoebox. Now let's add the saved shoebox. Now that we have seen how to organize and manage data with shoebox, let us see how pyramids and statistics can be computed for multiple images. Let us launch the image metadata and check the metadata of an image. Notice in the metadata that there are no pyramids and no statistics for this image. Similarly, there are other images that don't have pyramids and statistics. Let us launch the Image Commands dialog from the Manage Data tab. Give the image that we previously viewed in the image metadata as input. Check the box for Compute Statistics option. Multiple options like skip factor, bin functions can be given in the Options dialog. Check the box for Compute Pyramid Layers option. Multiple options like the algorithm and initial pyramid layer can be set in the Options dialog. There is also an option to create the pyramid as an external file or not. Click on the Batch button to launch the Batch command editor. Select the appropriate variable and add multiple images as inputs in the Batch command editor. Click on the Submit button. We now have options to start the processing now, or we can schedule it to run later, or do a distributed processing using Condor. Let us do Start Processing Now option, where we can increase simultaneous processes such that all the processes. Let us do Start Processing Now option, where we can increase simultaneous processes such that all the processes for the individual images start at the same time instead of processing one after the other. Now that the processing is complete, let us close these dialogues and check the metadata of the same image that we previously viewed. Launch the image metadata from the information group of Home tab and open the image. Notice that the pyramid layer algorithm and the statistics are shown as computed. Let us see how to auto-associate the sensor model information stored in the image. This can be done using a preference present in the elevation library category in the preference editor. By default, this information is not taken into consideration when we display an image in the viewer. The elevation part in the status bar is blank, and hovering the mouse over the image will not show the elevation information. Let us now turn on the preference option Sensor Model Should Auto Associate and save the changes. Let us now open the same image in the viewer and then check the elevation part in the status bar. Hover the mouse in the viewer and notice that elevation information is displayed in the status bar. Now that we have prepared our raster data and set the preference to auto-associate the sensor models, let us see how to collect and manage elevation source files including digital elevation model data and digital terrain elevation data. This can be achieved by Elevation Library Manager. Using this tool, multiple directories containing multiple elevation source files and individual elevation source files can be stored. The Elevation Library Manager simplifies elevation source file organization by storing the locations and relevant files of the elevation data in a prioritized list. There is also an option to set a level to filter the messages that are placed in the session log after the list of elevation source data are processed by the Elevation Library Manager. Now relaunch the Elevation Library Manager and notice that the collection of data and the changes done to the elevation data source is persisted until and unless changed explicitly. Let us now see how to auto-rectify an image without GCP. Let's display an image which has the sensor model information associated with it in the viewer by orienting it to the map system. Launch the inquire box and let's select the airport region. This is the region of interest to create an ortho image. Select the Auto Rectify without GCP option. Give the image displayed in the viewer as input. Select the appropriate geometric model from the list. The Geometric Model Properties dialog has different options. The elevation source to be used in the geocorrection can be changed from the available options Elevation Library, Constant and File. An elevation source can improve the results. Projection of the output ortho file can be changed within the Projection tab. The metadata of the input file can be viewed in the Metadata dialog. The different tabs in the dialog show the information stored in the file. All these information displayed in the dialog is read-only and any changes made are not saved. Once the changes are accepted in the Model Properties dialog, the actual resample dialog shows up. In this dialog, the elevation source information can be changed from the available options of Elevation Library, Constant and File. Since we intend to create an ortho of a specific region, let's click on the Inquire box button. Let us mention the output pixel size of the output raster image. Give the name of the output and run the process. Once the output creation is done, let's open the output image in a new 2D viewer. Switch on the north arrow and notice that the image is aligned to true north, indicating it is an ortho image. Let us now see how to perform a resolution merge by adding a corresponding model to the My Models tab, which has been newly introduced in ERDAS IMAGINE 2016. Out of the different options available for pan sharpening, let's select Modified IHS Resolution Merge. Give the input panchromatic and multispectral images. Select an appropriate layer combination method. Give the name of the output file and click on the View button. This would launch the Spatial Model Editor with the model that runs for Modified IHS Resolution Merge opened. Let's view the complete model by closing the viewer and hitting Fit to Frame option in the Spatial Model Editor. In order to run any model from My Models tab, the model should be equipped with port input operators. So let us add the port input operators to the two raster input operators and raster output operator in the model. Select the Add to My Models option to launch the corresponding dialog. Give the name and icon for the model that you wish to be displayed in the new custom tab, that is My Models. After giving the appropriate inputs, the My Models tab should show up with the model added as a ribbon button. All the models that are added to this custom tab can be found in the Models folder, which is created in the .imagine version-based folder on the machine. Let us now execute the model by clicking on the newly created ribbon button. This would launch a user interface wherein the inputs for the model are need to be fed. Since the model has a preview operator, let's look at how the output looks like by hitting the preview button. If satisfied with the output, we can generate the output by clicking on the Run button. Let's close both the 2D viewers and the Spatial Model Editor and launch two new 2D viewers. Let's open the original multispectral image in one viewer and the pan sharpened output in the other. Let's link both the viewers and equalize the scales. Let's use the zoom tool and zoom to one of the airport region. The image in the left viewer is the original low resolution multispectral image, and the image in the right viewer is pan sharpened high resolution multispectral image.